All right, let's talk about multiplying fractions. We start out with a problem 2/3 times 2. So I've got a figure that's divided into 3 equal sections, and I am going to highlight or shade 2/3 of those. So 1/3, 2/3. Now when I multiply that by 2, that means I just want to do the same thing over again. So 1/3, 2/3. In total, how many thirds do I have shaded? 1, 2, 3, 4. So 2/3 times 2 just gives us 4/3. And that's our geometric representation of multiplying those two values together. Well, what if I have something like 4/7 times 1/2? So I've got this figure here. Oops, I'm missing a segment. Got this figure here, and it's broken into 7 congruent sections. And we want to highlight 4 of those sections. So we're going to do that. 1/7, 2/7, 3/7, 4/7. So I've taken care of my first fraction, 4/7, and now I want half of that. Well, half of 4/7, or if I want only half of this group right here, half of 4 is just 2. So 1, 2. But again, these are sevenths that we took out of our original problem. So 4/7 times 1/2 leaves us with only 2/7. And there is your geometric representation there. Now, if you want to do this arithmetically and you don't want to take the time to draw out these figures, that's fine. And usually people will do this arithmetically instead. It makes it faster. So when you multiply fractions, 2/3 times 2, instead of leaving this 2 as a whole number, I'm going to divide it by 1. You can take any whole number, it doesn't matter what it is, and always divide it by 1, and it's still equivalent to itself. Now, why did I do that? Anytime that you are multiplying fractions, you are going to multiply numerator times numerator, denominator times denominator, every single time. And what does that give us? Well, 2 times 2 is 4, 3 times 1 is 3. So whether we do this problem geometrically or mathematically, not algebraically, arithmetically or geometrically, either way, we're going to get 4/3. Do the same thing with this one. So when we're multiplying, we just multiply numerator times numerator, denominator times denominator. 4 times 1 and 7 times 2. 4 times 1 gives us 4. 7 times 2 gives us 14. Now you might be thinking to yourself, Miss Guidry, problem. 2/7 and 4/14 aren't the same number. But they are. Do not forget, you can always reduce your fractions. 4 over 14, those are both divisible by the number 2. So I can divide this 4 by 2, and I can divide my 14 by 2 as well. I can divide them evenly. So what is 4 divided by 2? 2. What is 14 divided by 2? 7. And there you have it. 2/7 and 2/7. Now, I do know some people that would rather reduce their fractions before they multiply so that you don't have to work with numbers that are as large. And it wasn't too difficult with these two problems because 4/7 and 1/2, those aren't very large. But let's look at that right here. 4/7 times 1/2. If you want to reduce your fraction before multiplying, it is important that you compare a numerator and a denominator. I can say, okay, let's look at 4 and 7. Are those two values divisible by the same number? No, they are not. Okay, what about 1 and 7? It doesn't matter that they're not in the same fraction. 1 is a numerator and 1 is a denominator. 1 and 7 are not divisible by the same value. But what about 4 and 2? 4 and 2 are both divisible by the number 2. So 4 divided by 2 gives me a 2, and 2 divided by 2 turns into a 1. So now when you multiply your values, you end up with 2 times 1 over 7 times 1. And of course, 2 times 1 is just 2, and 7 times 1 is just 7. We still get the same answer.